Hey everyone, in this video we're going to talk about how to use your calculator effectively. It seems kind of obvious, a calculator should be easy, right? Just pushing buttons, but there's a lot of little things that you need to know before we get into calculus so that you know what to do with your calculator when the time comes. And I'm just going to give you a heads up. This holds pretty true. The AP exam allows your calculator on essentially 1/3 of the test. You have 6 free response questions. 4 of them are non-calculator and 2 of them are calculator-based. So about a third, and then the multiple choice is kind of the same ratio. And that's true in the class too. We're going to use our calculator about a third of the time. Sometimes it'll be a little bit heavier, sometimes it'll be a little less, but on average about a third. So with that said, the first thing we need to do is talk about batteries. You guys need to make sure that you have a new set of batteries available to you at all times. It takes 4 AAA batteries. And if you borrowed the calculator, or if you've checked it out from our library here, those batteries that are in there could have been in there for the last 2 years when the last student replaced the new ones, or maybe 6 months and they died. I don't know how long they last, but you need to have 4 AAA batteries available so you can plug those in at any time. You would not want this to die in the middle of the test or in the middle of the AP exam especially. So always make sure you have batteries. The second thing is, the on button. The on button is down in the lower left corner. And I'm going to be referring back and forth between my TI simulator here on the computer and on my camera, my actual TI-89, because some of the things on here are a little bit wonky. So first, how to adjust your screen. Well, when you push the on button, you're going to be in this home screen will probably pop up. It's actually not the home screen, but it's like our app screen. We're never really, well, can't say never, we're rarely going to use this. So you just hit the home button here, the home button, to get to your main screen. And you can see that now those 2 screens, the one on the computer and one on the camera, are the same. Now, you'll know your batteries are dying when this screen starts to fade out, when it gets lighter and lighter and lighter over time. So to adjust that, kind of cool, you're going to hit, so let me bring up the keypad here. You're going to hit the green diamond button, and you're going to hold that down, and then you're going to either hit the plus or minus button here to lighten or darken the screen. So like I said, if it keeps getting lighter and lighter and lighter, your batteries are starting to die. So you would hold the green button and then push plus, 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 plus. And as you do that, you would see your screen darken. If you want it lighter, you're going to hold the green button and then hit minus, 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 minus. So get that to the right contrast that you want and you're good. So that's how you adjust the contrast. The second thing is we want to make sure that we are in the proper settings for calculus. So what we're going to do is we're going to click on this mode button here on your calculator. And you don't have to change these settings every time you log in or every time you turn on your calculator. I will have to on the simulator, but you only have to change them basically whenever you change your batteries out. So the first thing you need to change is where it says display digits. Instead of saying float 6, that should say float 12. So scroll down here, float 12, and then hit enter. What that does is it takes your decimal place and it allows 12 digits after the decimal point versus 6. The more accurate we are in intermediate steps, the better off we're going to be. The next thing is our angle. If you scroll down just one, that should say radians. In calculus, we're going to be doing radians all the time. We will not use degrees. But if you are in physics or another class, you can change that between degrees and radians. So I'm going to put it in degrees and hit enter, but I don't want it in degrees. So I'm going to go back and change it to radians. Always radians all the time. The third thing we need to set up is scrolling down to where it says exact approximate right here. We don't want that to say auto. We want that to say approximate. We don't want our answers to be in radical form or some sort of simplified fraction. It's not that those are bad or wrong, it's just that calculus deals more along the lines of engineering and application of mathematics. And so in engineering, we want decimal answers so we can apply them to real life. And remember, we always round to the nearest thousandth. That's kind of like an engineering standard. So once you have those 3 things set, again, float 12 on your display digits, radians on your angle, and then exact approximate should say approximate. Make sure you hit enter to save that information, and now you're back into your home screen. So we're going to go through a bunch of tasks here, and I'm going to show you a couple different ways of doing things. So the first thing is, if I wanted to evaluate the sine of x plus 5 minus the natural log of x squared plus 7. If I wanted to evaluate that when x equals 2, 6, and 14, how could we do that? Well, we could type in this expression and replace the variable with each of these numbers each time. So we could hit the sine button is the blue button, so second sine of 2 plus 5, close the parentheses, minus your natural log is another blue button, so second natural log of 2 raised to the second power, close parentheses, plus 7. And then we can hit enter. And we can see it actually types in exactly what we wanted. It's in math type. And we can see that when x equals 2, we get 6.271. And that's fine. And then if we wanted to, we could go back in and we can, because this is already highlighted, we can go back in and scroll over and delete the 2 and replace it with the 6. Delete the 2, replace it with the 6, and hit enter. And so we can see when x equals 6, we end up with 2.416, and so on. We could do that with the 14 as well. But there's a few different ways that we can simplify this pretty easily so that we don't have to go back and retype in everything else. What I'm going to do is I'm going to type in the expression sine of x plus 5, close the parentheses, and then minus second natural log of x raised to the second plus 7. Okay, so that's my expression in the calculator. Now I'm going to go ahead and hit the evaluate button. So this vertical line here, under the equal sign, this vertical line is the evaluate button. So you just hit evaluate, and then you type in x equals 2. And so what this is saying is, it's telling the calculator, take this expression and plug 2 into the x values. And then we hit enter, and we can see that we get the same value that we got when x equals 2 before. Now, if you wanted to change that to the x equals 6, we can just scroll over and delete the 2 and put a 6. And it's pretty simple. It gives us our 2.416. And then if we wanted when x equals 14, we'll delete that, put 14. And then we have, so when x equals 14, we end up with 1.872 as an answer there. So you can see that that method is a lot easier. That evaluate button really helps us out. Another way to do this, and I find these ways pretty convenient, honestly, if you go to your Y list, you have a myriad of functions all over this calculator, and you got to familiarize yourself with them. If you go to your Y list, and that's right here, that's that Y equals right here. It's F1, but it's the green button. So we're going to hit the green F1, and that brings up a list of functions, basically. And so what we're going to do is we're going to type in our expression so that it's now a function. So we would type in second sine of x plus 5, close the parentheses, minus second natural log of x raised to the second, close the parentheses, and plus 7, and hit enter. So now we can see that that expression is saved as a function, and we name that function y1. Okay, now that is saved. So now we can go back home, hit the home button, and now we're back into our home screen. I'm going to go ahead and clear this stuff out. You don't have to, but I like dealing with a clear screen. Now, remember, we saved our function in the Y list. How do we get there? We hit the green F1 button. And notice we named it Y1, okay? So what we're going to do is in our home screen, we're going to type in Y1. That's going to reference our Y list. And then we're going to do parentheses X, close parentheses. This is just the way the calculator talks. By the way, whenever you're doing work on your paper or showing work on a test or something like that, you're never going to write down the keystrokes from the calculator. The calculator has its own language. Calculus has its language. The calculator has its language. You have to learn both so you can communicate with the calculator, but you never write down the calculator language on your paper. This is just saying refer to the function y1, and we're going to put it in respect to x. Now here we can hit our evaluate when x equals 2, and then hit enter. And you can see that we get the same answer that we had before. So instead of typing in the expression new every time, we could have it saved into our y list. Well, it wasn't that bad when I just typed it in once and then put evaluate x equals 2, x equals 6, and so on. You're right. But sometimes we have to graph the function. Sometimes we have to look at tables to see more information about the function. And so saving it in the y list actually makes it more convenient. And then again, we can go scroll over, delete when x equals 2, and put 6, and hit enter, and we get our answer there. So that's another way of doing that, saving that into your y list. Another way of doing that is to look at the graph of this function now. So remember, we were in our y list. We saved that as y1. Well, what we can do now is go to our graph. See the green button here, right here above the F3? F3 says graph. We're going to hit green F3, and that brings up the graph. Now, this is the graph of the function y1 that we saved. It's the graph of this really disgusting expression. And so now we have the convenience of seeing graphs pretty quickly without having to graph them on our own. There should be some that you know, like quadratics and polynomials and basic trig functions, but this one you would never expect to be able to graph on your own. Anyways, we're on the graph now, and we can actually evaluate these points at this function at different points. So what does it mean to evaluate this expression when x equals 2? It means looking at the graph, you're going to go over 2, and you're going to figure out how high it is. And this height should correlate with the value 6.2. And if I look over 2 and go up, over 2 and go up, you can see that that's around 6 point something. How do I do that? Well, I'm going to hit my F5. See that? It says F5 math. I'm just going to hit F5, and it brings up a bunch of options here under that math column. Number 1, it says value. So I'm going to hit F5 just like I did, and then I can scroll down to any one I want. I'm just going to go up to value and hit enter. And now it's asking for an x value. It says evaluate when x equals what? So I'm going to hit 2 and hit enter. So it says when x equals 2, the function is 6.271. And it even puts the cursor right at that point, 2, 6.271. That's pretty cool stuff. Again, checking the other ones, I'm going to go ahead and hit F5 again, value, and then I'll type in 6 and hit enter. And you can see that one. Now notice my window, if I hit my F5 again and I find the value at x equals 14, it says window variables domain. Well, what does that mean? That means that that point is not represented in the graph that is displayed here. So we need to adjust what we call our window so that we can see that point. I know I'm throwing a lot of stuff at you all at once, but you should probably go back and watch this video a couple times if you're getting stuck at anything while we go through. But anyways, to change your window, right now we have a domain essentially in a range that we're looking at, and it goes from x equals -10 to x equals 10, and y equals -10 to y equals 10. We can change that so we can see a bigger part of the graph or a smaller part of the graph. The way we do that is we look at our window here, and that's the F2 button, the green F2. So we hit green F2, and you can see our minimum x value is -10, our maximum x value is 10. Same thing with the y minimum and y maximum. Well, I need to be able to evaluate when x equals 14. So I'm going to scroll down to where it says x maximum, and I need to know that that goes beyond 14. So I'm going to just put 20 here. Now, I don't know the y minimum, y maximum. I don't know if I need to change that. I'm going to hit enter, and it's going to change my graph, look at my graph, but it's just changing the window, the domain of what I'm looking at. So I'm going to hit the green F3 button, go back to the graph, and now we can see more of the graph. And so we can hit F5 again, value, and then 14, and hit enter. And now that point is in the window that I'm looking at, and I can see it's 1.872. So that's how you can evaluate through your graph. So in calculus, there's lots of representations. There's what's called the analytic representation, which is basically the function, the expression, and doing mathematics through that. There's the graphical expression, the graphical representation, which is what we see in the graph here. Oh, my light went out. Let me fix that real fast. Okay, and then there's the numeric representation, which is tables, essentially. So you have the function, you have the graph, and you have the table. And so all three of those representations are really important to understand so we can see how the math works in all of them. So the last one that we're going to talk about in terms of evaluating is the tables. So the first thing we need to do is go to our table setting. So we're gonna, you see how we have the table button here? Well, if I hit the green F5 button, it brings up a table of values for the y1 function. Okay, a table of values for the y1 function. That's pretty cool. But notice when it gives me specific values when x equals 0, 1, 2, 3, 4, we'll talk about this infinity thing later. And I want to know when x equals 2. Well, I can see when x equals 2, it's 6.271, exactly what I saw here. And I guess I could scroll down and see the 6, right? 2.4 and 6, and I can scroll down further and see the 14. And that's 1.872. That's under the table setting. But let's say I wanted to evaluate something that's in a different set of numbers than just numeric digits counting, by ones. What if I wanted to evaluate when x equals 0.5? What I need to do is I need to change my table set function. Okay, so what we're going to do is we're going to change the setting of this table by pushing the table set. So we're going to hit green F4. That brings up our table set. Now, right now, the table is set to start at x equals -1, and it has a change in the table of 1. That means it's going to start at x equals -1, and it's going to increase by 1 each time. So that's why we had -1, 0, 1, 2, 3, because it was increasing by 1. So you can change this to say, well, I want it to start at 0, and I want it to show me increments of 0.5. And then you hit enter to save it. And then you can go back to your table. So you hit green F5, and oops, it's not showing it. What's going on here? Let's see here. Let me go back to the table set. We're going to change it to, again, 0. Scroll down, 0.5, enter. Oh, I need to hit enter again to save it. And then we'll go to our table, so green F5. And you can see that it starts at 0 and it increases by 0.5. You could do it that way. But another way to do that is this. We're going to go back to our table set, so green F4. And notice down here where it says independent. Right now it says auto. That means it's automatically setting it up according to the starting number and the change in the increments. What I want to do is I want to change that from auto to ask. So you hit ask, enter, and then enter again to save it. And it brings up a table again, but now you have the ability to edit these things. So I can just type in, okay, X, the highlighter is at 2, so hit 2, enter, and now it brings up that value. Go down if you want, hit 6, and then enter, and it brings up the value that we want there. Go down, hit 14, hit enter, and so it's asking you for the X values that you want instead of telling you which ones you get, essentially. And I can clear these values out to clear out the table. But now I can type in any value I want. When x equals 3.5, when x equals 72, I get these values. So that's pretty cool there. So those are all different ways to evaluate a function or evaluate an expression at different x values. You have the analytical approach, I guess you could say, by typing the function or the expression into your home button and putting evaluate when x equals whatever. You have your graphical approach, so you type it into y-list, and then you go to the graph, and then you hit F5, and then value, and then wherever you want, when x equals 5, there you got your y value, and it puts it on the cursor. You have your table option, your numeric option, so you can hit green table, and then you can type in the values that you want to evaluate at. Or again, you can go back to your table set and change that to auto and set up the table in a way that makes sense for what you're trying to evaluate. Because if I wanted to evaluate 1, 2, 3, 4, 5, then I would say start at 1 and give me increments of 1. And then I can get those values pretty easily. It just depends on what it's asking for. Okay, so those are the different ways of doing that. The next thing is to talk about the graphing component of the calculator. Now, I'm going to go ahead and type in this expression, and maybe you should as well, into the y list. Let's go ahead and type in, let's see, y equals x, well, let me redo this, x squared plus 2x minus 3 all over x plus 3. Ignore that. So let's type that into our y list. And we're going to graph this to get an idea of what this looks like. So we're going to go to our y list. So green y equals, right? Oops. Green y, okay? We're going to go up here and we're going to clear out that expression. And we're just going to type in our function that we have here. X raised to the second plus 2x minus 3, close your parentheses, because remember we need this all on top. So those parentheses tell you it's all on top. And then divided by parentheses x plus 3, close parentheses, okay? Now, I want to go to my window here, and I want to change this back to my normal window, -10 to 10, -10 to 10, and then we'll go ahead and graph it. So we're going to hit the graph button, so green, and then F3. And so we can see this graph. It looks a lot like a line. There's a problem with this graph, though, and if you were in analysis, pre-calculus, you should recognize that because the function has a denominator of x plus 3, there's an issue there. And we're going to talk more about that kind of stuff in the future. But notice that this function actually factors to x plus 3 times x minus 1 over x plus 3, okay? Rational functions here. So we can see that those reduce in a sense, and we're left with a linear function. But this function is not the same as x minus 1. It's very similar to it, but it's not exactly the same because we have an issue when x equals -3. If x equals -3, that means we're dividing by 0, and we can't do that. So this function is the same as x minus 1 in every respect except for that one point of x equals -3. And so if I were to look at my calculator, my grapher, and I were to evaluate F5 value when x equals -3, let's see what happens. If I hit enter, there is no value there. It's blank. Something's going on here. But if I look at my graph, I don't see anything wrong. That doesn't make sense to me. Why is there not an error there in the graph when it says that there is an error? So you can see that looking at a graph is not always the best idea on a TI-89 calculator. But here's what's beneficial. We can change the window so that we can actually see those holes, or we call them removable discontinuities, because the pixelation of the graph is such that it's just plotting dots every so often. It's not going to display it. But what we can do is go back to our window, and this is kind of helpful in some scenarios. We're going to hit the green F2 button, and we're going to change our window so that instead of saying -10 to 10, we're going to change our window to say -7.9 to 7.9. And then same thing with the y min and y max, -7.9 to 7.9. And then we're going to hit enter to save it, and then go back to your graph. Now, when I go back to my graph, I see the same exact thing. But I'm going to go ahead and show you what my graph looks like on, let's see here, on my actual calculator, the calculator that you would be using. If I hit the green graph button and I have the same function in there, you can see in mine that there's a little blank spot right there. Right when x equals -3, there's a blank spot. So when you have what's called the friendly window, the -7.9 to 7.9 in both the x and the y's, it will display any removable discontinuities that you have. Now, granted, it's pretty small, it's hard to see, and some people would just say, oh, it's a glitch, but that's not the case. Now, the simulator on the computer isn't showing that. Like I said, it's a little wonky in some respects, but the real calculator does. So that's kind of helpful there. That's called the friendly window. So in the window, it's -7.9 to 7.9 in both respects. And when you go to graph it, you can see the hole there. All right, let's move on to the next thing. And I know that there's a lot of information here, but it's a lot of good information. It'll actually make things a lot easier for you in the future. Normally, if we're in the classroom, we're rushing through this, and we actually don't get through it all. And as a result, students have a hard time knowing how to use their calculator in second semester, and that's not cool. So hopefully this is beneficial. So what we're going to do now is we're going to move into looking at a different function here, or a different set of functions. We're going to do some things with them. So what we're going to do is we're going to look at y equals 1/2 e to the x minus 3, and y equals 3 sine of 2x minus 1. Now, you should know how to maybe graph those, have an idea of what those graphs look like based on your analysis in Math 3 class, Algebra 2 class. But we're not concerned with that right now. So I'm going to go to my y list, so green F1, and I'm going to clear out the function that I have in there, and I'm just going to type these two functions in. So 1/2 e is the green button here. So see how it says e to the x? We're going to hit green, the x. And so it says e raised to what? Well, e raised to the x. We're going to close the parenthesis, minus 3, and hit enter. So that's my y1. Now in y2, I'm going to type in this function. So we're going to look at two different functions at the same time. We're going to type in 3 and then sine, so second sine of 2x minus 1. And then we're going to close those parentheses and hit enter. So now we have the y1 and y2 in our calculator. And we're going to do a few things with them. The first thing we're going to do is we're going to find the zeros. We're going to find the x-intercepts of each of these. And the second thing we're going to do is we're going to find the intersection of both of these. In order to find the zeros, remember analytically, you would set y equal to 0 and then solve it. But because we have a calculator, and if it's a calculator-based problem, we can do that pretty easily. So we're going to go to our graph. So we're going to hit green F3, and we can see our exponential function, and we can see our trig function. Now, I'm going to change my window to look at, let's see, I want to look at the exponential function first. So I'm going to actually delete the sine function and hit clear. So I'm going to graph that. And so now I only have the exponential function. I want to find the x-intercepts. What are the x-intercepts of y equals 1/2 e to the x minus 3? Okay, again, another way of saying x-intercepts are the zeros. The zeros. Now, normally we'd set y equal to 0. So in terms of work, we're going to say 0 equals 1/2 e to the x minus 3. And then this would be some sort of log function solving stuff. But if it's a calculator-based problem, the only work you have to do is say 0 equals that. That's your work. And now you use your calculator to get your answer. So to do this, you're going to hit the F5 button again. That's your math. You're going to use F5 a lot, math. And we're going to scroll down to 0 and hit enter. Now notice it brings up the cursor. It's asking for the lower bound. So where do we want the lower bound? When we say lower bound, we're talking about x values. So we're looking from left to right. So if I move my cursor over here and I have it to the right of the 0, that's not going to work. I need to pick a point that's to the left of 0. So I can pick any one of these points to the left of 0 and hit enter. Now it's asking for the upper bound. So I want to move the cursor to the right of the 0 and then hit enter. And so we see our x-intercept is 1.792, 0, if you would. And that's good enough in terms of finding that 0 there. Now, I'll bring up a common error that students have. If I hit the F5 button and I hit 0 and I go to the right, that's not going to work. If I hit enter, basically what it's doing, it's telling the calculator, look within this interval to find a 0. And so if I start at 2.5 and then I move over to 2.9, it's going to say busy, busy, it's looking for one. It says no solution found. Why? Because I started at 2.5 and went to 2.9. There is no x-intercept there, so you're not going to find one. Same thing if you're on the other side. If you start with a lower bound to the left of, let's say, 0.7, and then I say start at 0.7, x equals 0.7, and move and look for all the way to x equals 1.5, there's nothing there again. So you have to make sure that your lower bound is to the left and your upper bound is to the right. So that's how you find your x-intercepts there. Now let's go back to our other function. So I'm going to go back to my y list. I'm going to clear that guy out, and I'm just going to put in y2, 3 sine of 2x minus 1, close parentheses, and then we're going to go ahead and graph it. Now in my graph, I got a lot of zeros here, so I'm going to restrict the domain to be -2 to 4 as my domain. Okay, I just want to focus on that part of the domain. So I'm going to go ahead and, remember, change my window, so green F2 window, and I'm going to change that to -2 as my x minimum, and my x maximum is 4. And then hit enter, and then green F3 for the graph, and that looks specifically within a very small region. So if I were to look for the x-intercepts here, so if I were to look for x-intercepts of y equals 3 sine of 2x minus 1, well, there is 1, 2, 3, 4 of them. And so when you hit F5 and you hit 0, and you have to now pick a lower bound, you have to figure out which 0 you want. You can't be saying, okay, I'm going to go all the way over here to the left of this 0, and then I'm going to go all the way over here, all the way to the end here. Actually, I can make this quicker. 1, 2, 3, 4. I'm going to hit 4, and that's going to move my cursor all the way over to that side. That's interesting. Normally doesn't give you an answer. But you can see that there's 4 zeros here, and when you do that, it's only giving you the first one in this case, and your calculator might not give you any of them. So what you need to do is hit F5, 0, and then type in, you could scroll over, or you can type a number that you know is to the left of that 0. Well, this is -1, so I'm going to type in -2, hit enter, so it brings the cursor all the way over here, and then just to the right of that 0, so maybe x equals 0 for my upper bound, so 0 and enter. And so it brings me that 0. It's x equals -1.071. Now to find this next 0, F5 again, 0, I want a lower bound just to the left of this point, not to the left of that point. So I'm already on a point that's to the left of it, so I'll hit enter. And then maybe I'll scroll to the right, so I'll pass that point and hit enter. And so we see that we have another 0 at x equals 0.5. And then finding another 0, enter, and then we're going to go, however far you want. Just make sure you're to the left for a lower bound, and then to the right for the upper bound. So you need to, so that's a 2.071, and then so on. You can find the last one. I'm not going to do that for you. So with that said, you need to make sure that you're hitting your lower bound and your upper bound just to the left and just to the right, because you don't want to have multiple zeros within the interval that you're typing in, essentially. Okay, so that's how you find a 0. The last thing we're going to do is finding the intersection of 2 functions, because this is going to be something that's very beneficial to us in the future. So we're going to go back to our y list, and we're going to make sure that we have both functions typed in, the exponential and the trig function. So we got 1/2 of e to the x, and then -3 in the y1, and I already have y2 saved. So now I'm going to change my window back to -10 and 10 here, and you could change this one to -10 and 10, and hit enter, and then we're going to hit graph. And so we see our exponential, we see our trig function, and we can actually see that we might have some intersections here more so. So I'm going to change my window just for the sake of practice. I'm going to focus on that domain that we talked about with the trig function from -2 to 4, so that we're only finding the intersections in that region. So let's go ahead and take a look at that graph. So there's our exponential, there's our trig. We can actually see it looks like we have 1, 2, 3 intersections. And we're going to be using that intersection function throughout the year. So we're going to hit F5 for math, and we're going to go down to intersection. So scroll down, hit intersection. Now it's asking for first curve and second curve. So you just want to make sure your cursor is on one of the 2 curves, because sometimes you'll have 10 functions saved in your y list. Hopefully not, but sometimes you will. You want to make sure that you're finding an intersection of the 2 curves that you want. So you're going to put your cursor on one of the curves and hit enter. And now it's asking for the second curve that it's interested in. So you're going to put the cursor on the other curve. And the way you toggle is up and down. So I already put my cursor for the first curve there. I'm going to put the cursor on the second curve there. Now it's asking for a lower bound. Well, the intersection of those two functions, let's go ahead and write that down. The intersection, we know that there's going to be 3. So the lower bound, well, we want to be to the left of the intersection. So we're going to find this intersection point. So my cursor is already to the left. Now I can move between functions up and down. Doesn't matter. I just want the x value to be to the left of this point and not over here, not to the left of these points because I'm trying to find this intersection. So I'm going to hit enter because I'm to the left. Now it's asking for an upper bound. So I'm going to scroll to the right with my cursor. So I'm past the intersection and then hit enter. And so we can see that we have an intersection of 1.972. Okay. Now let's go ahead and find the other two intersections. So we hit F5, intersection, and then we're going to scroll all the way over here. Let's say I wanted to find this intersection right there. I'm going to move to the left of that intersection. Now it's asking for the first curve, so I'm going to put my cursor on one of them. It already is. Hit enter. Now the cursor is on the second curve, so I'm going to hit enter. And then now I want the lower bound, so I'm to the left of that intersection. I hit enter. Now I want the upper bound, so I'm going to move to the right, but I can't move too far. I don't want to move past the other intersection, so I'm going to move in between there and then hit enter, and it'll give me the one I want. So that's negative 0.511. And then we'll find the last intersection. So intersection, first curve, it's already on one of them. Second curve, it toggles to the other one automatically. The lower bound, we are to the left of that intersection. We don't want to be to the left of the other one. And now we want upper bound, so we're going to scroll to the right, hit enter, and it's going to put the cursor right on that other intersection, which is 0.009. Now, just keep in mind that these are only x values. It's not the actual point of intersection. We would need the y value as well, but it happens to give that to us here. So that's kind of how you need to operate your calculator. Those are the main things you have to do. You need to know how to graph a function, find its zeros, find its intersection, evaluate, and then later on I'll show you how to use your calculator to find derivatives and integrals and things like that. I know this video was kind of long, but hopefully it helps you in navigating through your calculator effectively. And if you have any questions, make sure you reach out to me. Otherwise, I will talk to you later.